Yeah, warm good afternoon class. In the previous video, we have seen what is fracture mechanism, what is fracture mechanics, and we have seen what is fracture, and we have seen what is ductile fracture eventually, right? So now we are going to see the second type of fracture, which is known as brittle fracture. So in this, you can easily say that this brittle fracture that can be easily explained like once you broke a chalk piece into two. Okay, once you break the chalk piece into two, you'll see some flat surfaces like this that happens, right? So that is nothing but the brittle fracture. So that's the same way in the brittle fracture as well. See, we cannot break the chalk piece with a light load. Means that up to some critical loading condition, that chalk piece will withstand the load what we are giving. So we are giving a load above this critical level. So once you break it, it get broken. So here you can see the ductile in this brittle fracture. You can see it is broken into two halves with some flat conditions. It means that the broken surfaces are looks like very flat. So there is no plastic deformation that occurs as like the ductile fracture. So here the plastic deformations that you can see some. See, I can easily explain here. So if you pull a rubber band, okay, it's plastic in nature, right? If you pull a rubber band, if you pull it on over, the big rubber band will get stringent, and then only it's going to get tired out. As like that's the some example of plastic deformation. As like that, in this way, you cannot see any type of that mannerism in the brittle fracture. So here it will not show any condition that it is going to get failed. So because of this fracturing mode, if a material is getting in the is get fractured in the brittle mode, we cannot see any plastic deformation, or we cannot see any significant features that is going to get failed, or we cannot see any indications that the material will get failed. So upon using this type of material, that is brittle material in the industrial applications or application, or in any application, you can see if it is going to be broken suddenly, so we cannot predict it earlier. So then there will be a catastrophic damage for the materials or the application, right? So next one is the fracture mechanism. So for this both ductile, brittle, or fatigue and creep, we will follow this fracture mechanism. The first one is imposed stress. Means that the stress what we are applying on a particular material, means this stress will be applied on a material over and over with some increased magnitude. Okay, for example, if you want to first we are applying a load about 1 kilo, 1 newton, 2 newton, 3 newton, 4 newton, 5 newton. So this force level is going to get increased, that is known as imposed stress. Means we are going to apply the stress over a material in the higher in the increasing order of magnitude. Second one is crack formation. Once this load is applied, see, any material will withstand the load for a certain condition, for a certain limit. That limit is known as critical limit. Once the critical limit is reached, so after reaching the critical limit, we are going on or keeping on applying the load. There you can see the crack or the void for crack formation will get started, right? As I will say, see, take a stick and broke it like this. Okay, once if the stick is straight, we can easily bend it. So once beyond the limit, if you are bending, you can see some crack sounds. That is the sound where this crack formation is happening. So even after hearing the sound, if you are going to apply a load like this, you can see the crack will growth. You will have a growth, or which is known as propagation. So this crack propagation will occurs at the area, so that once the crack is propagated, you can see the crack propagation is happened. The crack growth, you can see the crack growth. So upon seeing this, even you are applying the load like this, the crack propagates, and at last the failures will happen. So this type of failure, what I shown now is for ductile failure. But for a brittle failure, it is somewhat different. The mechanism is same, but it will not show any type of significance that the material is going to get failed, right? It will not show any significance, then it will fail very rapidly without any significance. Okay, that's all for today. We'll see the rest of the fractures in the next class. Thank you.